In this video, we will review trigonometry. To start with, trigonometry is a word that's made up of three parts. The first is tri, for 3, then gon, for sides, and metri, for measurements. So basically we are talking about the measurements of polygons with 3 sides, i.e. triangles. And this will be restricted to right-angled triangles, at least for the time being. Before we review the basic principles, let's consider the idea of the trigonometric ratios and the concept. If we have a right-angled triangle, A, B, C, with a right angle at B and an angle of 40 degrees at A, and we scale it up to get the triangle DEF. Those two triangles are obviously similar. When you scale triangles up, the angles remain the same, and we know from similarity that the ratio between the sides remains the same. So the ratio of O1 divided by O2 is the same as A1 divided by A2. Basically, this is the scale factor. With a little rearrangement, you will get O1 divided by A1 equals O2 divided by A2. And this is a very significant result because it shows you that for any right angle triangle with an angle of 40 degrees, the ratio of the opposite to the adjacent is constant, no matter what the triangle is, large or small, as long as this angle is 40 degrees. Before we start, let's review some basic terminology and important remarks. In this right angle triangle, if you are considering the angle A, then as far as A is concerned, this side BC is called the opposite, while this side AB is called the adjacent. However, if you're considering the angle C, then this side AB is called the opposite, and this side BC is the adjacent. In all cases, AC is the hypotenuse, and that is the longest side in the right angle triangle. You should also know how to denote the length of the sides. In the triangle ABC, the side CB has a length of little a. So the little a here denotes the length of the side, and we can determine that this is A because it subtends the angle A. Little b subtends the right angle B, and little c is the length of the side that subtends the angle C. Now, to review the 3 trigonometric ratios, we have the sine, so which is sine A is equal to the opposite, BC in this case, divided by the hypotenuse, AC in this case. And obviously for a given value of A, like let's say 40 degrees, this will be a constant. Again, cosine A is equal to the adjacent over the hypotenuse, and tan A is the opposite over the adjacent, which is in this case BC divided by A. Some people like to remember those 3 rules, and they call them SOHCAHTOA. This is not trigonometry, it's just a mnemonic to remember that the sine, S for sine, is equal to the opposite over the hypotenuse. And the cosine is the adjacent over the hypotenuse, while the tan is the opposite over the adjacent. Now consider this same triangle, but when you're considering angle C, sine C is the opposite, which is AB in this case, divided by the hypotenuse. And cosine C is the adjacent, which is BC, divided by the hypotenuse, and tan C is the opposite divided by the adjacent. So obviously sine A and sine C are not equal if the angles are not equal. Now let's apply. The first application is using the trigonometric ratios to find sides. Let's say that we have this right angle triangle ABC with BC as 5 centimeters and the angle A as 38 degrees. And let's say that our objective is to find the length of the side AB. Now we look at the triangle, we know the angle A, and we know the side that is opposite to it. And we want to find AB, which is the adjacent to 38. If we have the opposite and we're looking for the adjacent, then the ratio that combines those two sides is the tan. So we write tan 38 equals 5 over C. 5 is the opposite, and little c is the length of the side that is opposite the angle C. With a little manipulation, cross multiplication, this gives you C equals 5 over tan 38. And now we go to the calculator. 5 divided by tan 38 equals 6.3997. So let's say this is approximately equal to 6.40 centimeters to 3 significant figures. Let's say that we have the same triangle, but we want to find the length of AC, which is the hypotenuse. Obviously, you can go back and use Pythagoras. However, the disadvantage of using Pythagoras is that the 6.40 would be a rounded figure. So if you use it in a calculation, you'll probably lose a little bit of accuracy. But it will still be a correct method. And you can avoid the loss of accuracy by taking 6.40 to more than 3 significant figures. But let's say that we want to use the numbers that are given in the question. We have the opposite to 38, and we want to find the hypotenuse. The ratio that combines the opposite and the hypotenuse is the sine. So we write sine 38 equals the opposite, which is 5, divided by the length of the hypotenuse, which is little b, because it's opposite the vertex b. By cross multiplication, we get b equals 5 over sine 38, and again 5 divided by sine 38 equals 8.12 centimeters. And if you check, this is the answer that you get by Pythagoras as well. The other application of trigonometric ratios is finding angles. Let's say we have this right angle triangle. We have 8 centimeters for AB and 12 centimeters for AC. And we want to find the measure of the angle A, denoted here by theta degrees, or you can simply use the letter for the vertex. Now what we have as far as A is concerned, we have the adjacent, which is the 8, and we have the hypotenuse, which is 12 centimeters. And the ratio that combines the two, the adjacent and the hypotenuse, is the cosine. So we write cosine A equals the adjacent over the hypotenuse, 8 over 12. Now we want to find the measure of the angle A. So what cancels the cosine is the inverse cosine. So we take the inverse cosine of both sides. Cosine inverse of cosine, they cancel each other. They are the composition of inverse functions, as it were. And you're left with A equals cosine inverse of 8 over 12. This notation is necessary. And please pay attention, this inverse does not mean 1 over. It means the inverse function. And in order to calculate the angle A, we say shift cosine gives you the inverse cosine of 8 over 12, and this equals 48 degrees to the nearest degree. So this equals 48 degrees approximately.